Hello and welcome. In this video we're going to talk all about functions in R. In particular, we're going to stress why it is that it's about time that you start consider writing your own R functions. We'll see that R makes this very approachable and readily achievable with the level of R knowledge that we have thus far. So what are these things? Well, functions, they're typically self-contained pieces of R code that are written to carry out a specified task. And now using functions is the very essence of using R. We call functions to read our data in the first place, of course, to do some analysis, some statistics, for example, to make a plot, etc., make reports, all these things. It's the job of our user is to call functions to do our work. So every function in R, whether it's your own function or it comes from somewhere else, it has three common parts. Now, they're labeled here. The first is a name that we use to call the functions. Now, if this is your own function, of course, you can pick whatever name you want. Almost anything will do the job here, apart from words that begin with numbers, for example. Now, the second thing that almost all of our functions have are input arguments. These are the inputs to the function, and often there can be more than one of these. For example, here there are multiple. There are two comma-separated input arguments. Now the third thing is really the main heart of the function, if you will. We actually call it the body. It's all about the body because it's where the actual work gets done. Typically, this will be our code that's executed line by line in the typical fashion to achieve the goal or the effect of the function. So let's have a little example. Here's our first example, and it's a little bit of a silly function here, but we'll work with it because it'll build up it'll get us warmed up here for where we're going in this video. It's silly because we can add numbers in lots of ways. We can just use the plus, or we can use the sum function, for example. But here I've called this function add because, well, that's what it does. It takes so it's called add. It takes two input arguments, x and y, of which notice that only x is absolutely required to use this function, because y here is, I've given it with a default value because I've written y equals 1. That means if the user does not give a second argument, y will assume the value of 1 and use that later in the body of the function. And then the body here is really simple. It's just x plus y. And because this is actually the last line of the function, it'll be the answer here that's returned to the user when they call this function. So let's give it a try and see how it works. So let's shift over for a moment, and I'd like you to do this too, please, with me, is shift over and open RStudio and see how this little add function works here. So here I am in RStudio. I'm in a new blank project. As you can see, I'm going to open a new text file, a new R script here, just to store my work as I go through, so we can see the commands that I'm typing so they don't disappear off the screen as I go through, in case I go through too fast here. So I'm going to do File, New File, R script, and this will open a blank script. It's called Untitled here. I'm actually just going to go and save it. I'm going to click the little disk icon or Command S, and I'm going to save it as functions.r. Save it in here. We should see that in the Files panel. Up here, the script, it's currently got 0 bytes in it because there's nothing in it. So I'm going to write out I could copy and paste it. I'll just maybe just type it out. That's always good experience for us. So I'm going to do function, how we define the function, and then I'm going to do x, z, x, y equals 1, and then the body of this function, it's x plus y. I'll maybe give it a little bit of space. Okay, so that's my function. It's called add, and well, nothing's happened. R, I can't use it, I can't do anything with it because R doesn't know anything about it. Notice that my environment over here is empty. So I can do this a couple of ways. I can highlight this code and I can copy and then paste it down into the R brain, down into the console down here below, for example. Or I can highlight it and push the command return. That will do the same thing. Oh, I need to spell function correctly. That'll help. Let's try that again. And now, if I clean up my drop-ins, you'll see that I've pasted that in, and the add function with the function here is available. I could click on it, it would show me it, but it means that R now knows about my function and I can actually use it to do things here. So if I then try and test it out, so I could do add x equals 4. So what would we predict this gives? Well, it's going to, the first argument is going to be 4. I'm not giving it a y argument, so it's going to be 1. So it's going to be 4 plus 1 is 5. Let's try it out. And I see indeed down here in the console, my answer is 5. Now I could give it 2 arguments, like x equals 4 and y equals, let's say, 10. Okay, and then I could send that down and I get 14. 10 plus 4 is 14. So the y, that argument is working here. It seems happy. I could call the same thing without explicitly naming x and y. So 4, let's do 20. Here's, so R is smart enough to know if you don't name the arguments that the first one will be x, the second one will be y here. And it goes and gives me the answer 24. So what if I change this and said, let's make this 10. Let's give an input vector here. So I'll give 1, 2, 5, 10 as an input vector. And I'll put some spaces here just to make it easier to see. So I'm given x is going to be this vector of 1, 2, 5, and 10, and y is going to be 10. I'll just spell it out to make it clearer. So this is going to work. It's vectorized, so 10 is added to every element of x, and we're pretty happy with it. That's how we'd expect this or hope it would work. I wouldn't need to, do some looping through every element of x to make this work the way I want it to. So what if we did add, and we give it a vector again. Let's give it our 1, 2, 5, and 10. And we'll give our y equals 10 and 20. What will this do? Well, what do you think? What should happen here? Well, if we think about it, it's probably nonsensical to do this because I'm giving it 3 inputs here. And my function, if you remember up above, you can see it up here. It only has 2 inputs. So when I call this, what R is going to go is going to say, no boss, I love you, but there's an unused argument, that number 20. I have no idea what to do with it. I'm out of here. I'm not going to do anything. And it gives you this error message. Because I'm giving it an input argument that the function doesn't know how to handle. So that's fine. That's the error message that there is. We could later on in our hands-on session, we'll see how to make these error messages a little more friendly for the user. Let me see what would happen if I did something different. Let's delete it here so we can keep everything on the screen. So say we have our input vector of 1, 2, 5, 10, and we added y equals something like this. Now this is, of course, again, nonsensical, because what's going to happen here is it's going to convert to a character vector. How do you do math with strings? Well, the answer is you kind of can't. It says non-numeric argument to binary operator. When we do that addition inside the body of the function, it doesn't know how to do it, and it'll give you an error message. And this is probably a sensible result here. It mightn't be the friendliest error message in the world, but again, we'll see how to tailor these error messages inside our own functions in our hands-on session on Thursday. So let's move on from that little add function, which is a bit of a silly example, and build up to something more realistic, where we'd actually want to think about writing a more robust, useful function. So I'm going to return to the slide display here, and we're going to look at some code. So this is a bit of code that I've taken from this book, the R for Data Science book that I've mentioned a couple of times by Hadley and Garrett, and it's in chapter 15 of that book there, where they're talking about R functions and what motivates us writing functions. And so let's have a look at their code. So what is this code doing? Well, the first thing to note, maybe the most striking thing when we look at the screen here is that the lines kind of look the same, right? The first line, the second line, third line, fourth line here, they're kind of look the same. And that's because, in fact, they're doing the same thing over and over. And the first line is taking something called df $A as input, and so that's a column of a data frame, most likely called df, and it's doing something to it. And then the second line, it's doing similar sort of thing for $df$b, and on the third line for $df$c, and for the last line on $df$d. So it's working on different columns of the same data frame here. And what is it doing? Well, if we look at that first line, what it's doing is it's taking the column, the $df$a, and it's subtracting the minimum value from that column. So it's calculating the minimum numeric value in the column, and it's subtracting it away from all entries. Then it's putting that together in the top of a little fraction, or dividing by the range. That's the maximum value in the column minus the minimum value in the column. So what this will achieve here is it's actually called scaling or rescaling of numeric values, so that they'll all lie, in this case, between 0 and 1. And this is something that we do quite a lot before we do further analysis. Otherwise, a lot of analysis that we might do might be potentially sensitive to values that are measured on different scales or on different units that are of a different range. For example, if we had some data that's measured in millimeters or kilograms or something like that, people's height in millimeters and weight in kilograms, those measurements are in quite different scales. One will be in hundreds, one will be in tens, hopefully, and so any analysis that we might do might be more prone to weighting the millimeter measurement just because it's on a bigger range more prominently than the one that's measured on the smaller range of values, for example. So we'll rescale them, and we do this a lot in bioinformatics. We rescale counts and all sorts of things to make comparisons more fair. So let's see how we could do this. Let's have a look at this code and see how we do it. Well, the first thing when we look at it here is actually something that's quite dangerous. It's kind of silent and deadly mistake here that came about because this was a copy and paste job. We wrote some code and it worked on $df$a, so I just pasted it 1, 2, 3, 4 times, or 3 more times, and then I edited all the A's in the second line to be B's, but I missed one because I'm human and attention spans wander, and I just missed it. I just made a mistake. And the same thing happened on the last line. You see, these should all say $df$d on the last line, but I forgot to update one. It still says A. So this is risky and dangerous and problematic because it's not going to give an error message, right? It actually is a valid calculation to do, but it's going to give the wrong answer. And that answer will not be shouted about or give an error message or some other warning or something like that. It's just going to keep on going because R loves you and it'll do whatever you tell it to do. And this will cause trouble. So we don't want to live like this. We don't want to work like this. We don't want to have all these copied and paste duplicated code in. We want to take it and write a function. So what might this look like if we did it properly? Well, here's an example. I made up the name rescale here, and it'll take the input $df$a, and this looks way better than the code that was on that last slide, right? Of course, it makes the purpose of the code more clear. It's a lot more compact and readable. It reduces those mistakes that will creep in from copying and pasting and human nature. It'll make updating the code easier in the future. If I wanted to rescale between different values, for example, I only have to do it in one function. I don't have to edit every single time I pasted this all throughout my project, my analysis workflow. And it'll make duplication and reuse in other projects a lot easier. Okay, so hopefully those sound like good positives, good advantages, and that it's something you want to consider doing. When you find yourself doing the same thing multiple times, it's time to start thinking about going to the next level and making things more robust in this function approach. So how would we go about this? Well, the first thing that we do is we identify the repetitive component, the thing that we're doing multiple times, the thing that's causing us to think in this way in the first place. So in that code, the original code there, we can start with the first line because that's the thing that's being repeated over and over again. And we can take this and we can make it into a little snippet, extract it out here and simplify it. So the next thing is simplify. Rather than working with $df$a, that named input, I'm going to change it to work with a generic vector x. You'll see x used a lot when we're talking about vectors in R, and I'm going to follow the same practice that the rest of the world does and work with x here. And already my code here is much simpler to read, I think. So we're working on x, and now I can kind of see that we have some duplication here. Notice that this min function that I'm calling to find the minimum numeric value in that vector, I'm doing it twice. And this is kind of a waste, right? You know, if I did it just once and stored the answer and then used that answer each time, I'm going to save myself some time and some work. You know, practically this is not going to make a huge difference, this saving, if we're just working on small vectors. But if we're working on hundreds of thousands of things, this is going to take a fraction of a second, and it's going to save some time, right? It's going to actually make our code more efficient and faster. And that's a good thing. So what I'm going to do is take that min call out, and I'm going to save it as a intermediate object, an xmin, a temporary variable, if you will, and use that xmin each time that I previously used the call to min here. Okay. So as I'm going through, you know, this is looking much better, much clearer, much more efficient. But you might know, or maybe you don't, but I'll tell you now, there is a function in R called range. And what it does is it actually goes and finds the maximum and the minimum value of a numeric vector and gives you them all in one shot. It actually returns a two-element vector with both answers in it. So I could, if I knew about this range function, I could go and I could use it instead of the min and the max function, and use the first element of the answer as the minimum and the second element as the maximum, and use those values in my code. And I've made things again simpler here in this case. So I've reduced code duplication, I've simplified, and I've got pretty much to where I want to, as far as I want to take this for this example. So what do I do next? Well, now it's time to go and put it into the body of a function and pick a name for it. So in this case, I'm going to pick the name rescale. It's a good name because it makes the purpose explicitly clear. It's kind of self-documenting in essence, and that's good. That's good practice to do that. And then I've got my refined little snippet, and that's the body of my function. That's right in there between those curly parentheses. So now I've got that, I can go and test it. Right? I can test it on simple input vectors, like here in the last line here, I'm testing on an input vector 1 to 10. Now it's important you don't just go and test it on your big, huge, 60,000 gene expression set thing, and then you don't know whether the answer is correct or not because it's got 60,000 things in it, or you don't know what the answer should be. But we test it on something small, manageable, where you know what the answer should be. Because our objective here is to test, see if it's correct, of course. That's a minimal requirement to being a good function, but also figure out if it's robust. If we fail, does it fail in a bad way that might come back to bite us on the butt later, or haunt us, or cause problems later? We want to find that out and stress test it now, and if necessary, fix it so it doesn't cause us heartache later. So let's again pop over to RStudio, and we'll take this first version of this rescale function in and see how it works. We'll test it and follow this process. So please open RStudio again, or flip over to it and follow along with me, please. So here I am back in RStudio here, and I've got my work from earlier. I'm just going to save it, and I'm going to give myself some real estate, give myself some room, and I'm going to write a comment, our second function, rescale. Okay, so I'm going to take it, and I'm going to I'll just actually paste it in this case. So I'm going to go to my slides here and copy and paste it in. And again, R doesn't know anything about it yet, right? So here I can't go and type rescale. It's not going to do anything. It's going to say error, I could not find the function, because I haven't told R about it. It's not listed here in my environment. So I'm going to take it, and I'm going to make sure R knows about it. I'll just paste it in for this example. And here, finally, it appears, and I can use it. So if I'm in my console, for example, here, I can type re, and I can see that it auto-completes. It's a first-class citizen, same as every other function. It's just that easy to make these things, right? I've just pasted it in, R knows about it, and I can auto-complete, and I could give it some input, like 1 to 10. And it'll do its job. In this case, it rescales to lie between 0 and 1, and that's the correct answer. Let me save this in my script, so I have the record of my work. So I'm going to test on a simple example, and I'm going to save that, and I can run that again, and it'll work. Okay, so that's fine, and I can test it on more numeric vectors and check if it gives the answers that I'm hoping for. And I could test it on things like, maybe I'm running my experiment and for whatever reason, the instrument has a blip or other data entry problems or something like that, and I miss a value. I have an observation that's missing. So say if I had some values like 1, 4, 10, and 20, right? So this will work because I don't have missing values. Happy days. But if I had a missing entry in here, maybe the second time point or something like that, the second entry is not available. R uses NA to represent not available entries. So this is like a missing data point. What happens if I run this? Well, first, let me think about what I would want it to do. What would I expect, or what would I hope my function to achieve? Well, maybe you want it to shout at you and say, "Whoa, boss, you something went wrong earlier on. Go back and see why you've got a missing value." Or maybe you want it to actually just keep going. Maybe you've got, it was lots of hard work to collect all these samples, and that one that's missing, okay, it's missing, but let's work with what we've got. So either of those scenarios, of course, it's your choice. It's up to you how these things work. You're master of this universe, so to speak. So you can make your functions work however you want. But in my case, I'm going to say, let's do that second. Let's say I want it to rescale all the values, but give the NA back for the second position. Is that what my function does? Let's check. I'm going to push command return or control return here to send it down to the R brain. And I see down here that it didn't work that way. It actually gave NA, 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 or na, 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 na. It's like laughing at me, right? Na, na. It's not what I wanted. It returns NA for everything. So why is this? Well, I'm going to have to fix this. This is not a sensible result. It didn't shout at me to tell me that there's missing values. It didn't rescale the values I wanted it to rescale. So let's look at our code again. So here's our code up here. And I can see, I'm going to go line by line and see if I can figure out what's happening. Well, the first line is where I call this range function, the range of x. So I'm going to take that and try it. I'm going to check. So here's my input vector, this thing. I'm going to copy that. And I can then wrap it in a call to range. So here's range, and I push return, and it gives me NA, NA. So that's going to go in the second line of my function. The range 1 is going to be NA, so it's x minus NA, and it's going to be divided by NA minus NA, and it's going to return NA for every single input. So this is where it's coming from this range function. So let me look at the help page for range. I'm going to type question mark range, or you can push function F1 here if you're over the name of the function. I'm going to just type it out, so question mark range. And it brings up the help page. Let me make that a little bigger here so we can all see it. And here I'm reading the help page. The usage tells me that I can have multiple arguments, and there's a second argument called na.rm equals false. So what's this thing? Well, in the arguments it tells me logical, so that means it's either a true or false value that's allowed here for this argument, indicating if na should be omitted. Omitted means left out. So probably if I flip this na.rm to be true rather than false, I might make progress. So let's test it and see what happens. So I'll close this up for a second, go back here to my console. I've got my range. I'm using my up arrow to recall my previous commands. I'm going to add a second argument, na.rm equals true. And in this case, when I push true, or push return, sorry, it actually gives me what I want. It gives me the minimum, which is 1, and the maximum, which is 20. So this should fix my problem. Let's check it out. I'm going to go and I'll write a new version of this function. I'll copy this old one here, and I'll take it and I'll call it rescale NA, or maybe I'll call it rescale 0, 1, for example, because it rescales between 0 and 1. I'm going to actually give it here, I could hard code it in here, na.rm equals true, for example. We'll see that we can do better in this in a second, but I'm going to, again, I can't use this function yet because the R brain or the R environment doesn't know, it's not in the environment, the R brain doesn't know anything about it. So I'm going to send that down to R, and now it's here. You can see it over in my R Studio environment panel, and I can test this thing that give me my error before. So let's see. I'll add a little comment so my future self knows what I was doing. Fix the NA issue, for example. And now here I'm going to call the correct function, rescale 01. So before, if you remember, I'm going to do the one before it, give me all NAs. This time, if I push the right keys, it'll send it down and it returns what I want. It returns the first. If I rescale the second, the missing element, it can't do anything with, so it returns NA, then it rescales all the rest. So I'm happy. I've got it where I want to be. So of course, there's still limitations to this function. It still doesn't give me, error messages or check that the input's numeric. So for example, if I did rescale 01, that's our best version, and give it some input like 1 for string, it's still not going to work, right? It's not going to, I can put any word in here, right? It's still going to give me some error message, non-numeric argument to binary operator. Non-numeric means there's something that isn't numeric in your input and I'm trying to do math with it and it ain't going to work. So that's probably a good thing, right? You don't want it to go ahead and proceed and give some output silently back to the user. You probably want to know that a word or, for example, a gene name has slipped into your column of expression values or something, because that means your data input was probably messed up or something earlier on and you want to know about it. So you probably want to shout and feel early and loudly is the common mode of working here. So the user can go and fix these things. So for now, let's leave this rescale function and go back to the slides for a second. I'll save my work. One thing before I move on is we've written something that's kind of useful, this rescale 01. Now if I wanted to use this anywhere, like in a future project, I'd have to get it into my R environment. And I could do that if I save this as a new file. So let's test this, for example. I'm gonna restart my R session. So now it's blank, right? So all my environment is empty and I can't use you see rescale doesn't come up. It's just not a function, it's not available. I can go and save this as a separate file. So if I opened a new file R script and pasted this in, and I should write some comments here for my future self so I know what's going on and why the na.rm here. I could actually change this. Let's give it a new version, rescale 02, and I could give it na.rm as an input argument, and I could flip it to true and then use that down here. And I could save this as rescale 02. So if I save, now I'll have this in my project directory of this rescale 02. I can source this. I'm down here in my console. I could do sour source and then rescale 02. And now I have the function in my environment. So anytime I want to use it in the future, I can do it, right? So 1 to 10. So in another project, I could use this. So I have the script. I've made myself a useful utility, a useful function that I could use in my future work. Okay, let's go back to the slides for a second and we'll finish up this section. So we could, of course, keep going and keep testing and keep failing and improving. And it's up to you how much you want to do this for your particular purposes. And eventually, you might turn these tests into what we call formal unit tests. That's something we won't get to in this video, but it's a way to make sure your code doesn't break inadvertently, for example, when you make changes elsewhere. But here, what I've done is, I've taken our little rescale function, I've taken it far too far here and made it actually a little bit ridiculous, in fact. And the idea here is that it's to show you how this function works. It goes in line by line, and I've added the na.rm argument here to the function, but I've also added a third input argument called plot, which is another logical, and it's false or true here. So if I say true, it's going to go in, and you'll see there's an if statement here, and if evaluates true, it'll go into the statement and make a little figure, a little plot of my values, a little diagnostic thing. There's also some print values here, so we can check how they work. Let me take this code and bring it back to RStudio one last time and test this out. So I'm going to take my rescale, and I'm actually going to paste it in here. So I'll save that up, and I'll source this thing again. I'll make this a little bigger so we can see what's going on. So I'm gonna source that rescale. So now here's my rescale function. I could click on it to see the code, right? And so here it is. And it goes in, and it's going to go line by line. And it's going to say, do the calculation. It's going to print hello. So let's see how it works. Okay, so if I do rescale, and I say 1 to 10, for example, it's going to say, hello, is it me you're looking for? Okay, I'll stop singing, right? But you get the idea. It's gone line by line, it's printed out what I want. If I added that argument plot equals true, well, it's not going to, it's going to make a little diagnostic plot, and that might be useful, usually probably isn't. Okay. So in our hands-on session, you'll get an opportunity to write these things yourself. We'll work through a couple of more examples. In particular, you'll get an example to write a function called grade, which will determine an overall grade from a vector of student homework, like the assignments you've been doing to date in the class. And we'll also add the ability to drop your lowest scoring assignment here, or alignment score. It shouldn't be alignment, but assignment score here from your overall calculation of your grade, for example. And then we'll take that function and we'll make it work on the entire class. We'll be able to grade everybody's work to date and see what kind of scores we're all sitting on. We'll take some data that doesn't have our names in it, of course, but it'll be our student work, and we'll write a function that will help us in this class figure out your overall grade. The other thing that we'll do, and this will be for homework, is we'll take some code that's real research code that's doing something interesting, like in this case looking at the effect of drug binding on protein flexibility, in this case a kinase, and a new drug that we're testing in this case. And some of these drugs have an effect on how the kinases work by affecting their flexibility. And we're analyzing these 3 different drugs, but we can see here we're doing the same thing multiple times. We're repeating ourselves. It's this dry, DRY, do not repeat yourself mantra that we want to stick to. We want to abstract this and make it into a function, so we could do it for every protein drug interaction that we might come across in the future. That would be a useful bioinformatics functionality to have, rather than copying and pasting the same repetitive code each time. So that'll be your homework, to turn that into a function. I'll finish by recapping what we've covered. We've covered the when, the why, the what, and the how of writing your own R functions. The when is when you find yourself doing the same thing 3 or more times with repetitive code. You should consider writing a function. The why is because it makes the purpose of your code more clear. It reduces mistakes from copy and paste. It makes updating your code easier. It reduces code duplication and facilitates reuse. The what is, a function always has these 3 main components: the name, the arguments, and the function body. And I'll finish there. And in our next video, what we're going to do is we're going to point you to one of the best features of R, one of the reasons why R is so popular. That's where expert defined functions written by other people, other users, are available in these R packages that will really extend the functionality of R. And we can go get those, especially for bioinformatics. It's going to make our life a lot easier. We can use these best practices, expert created functions from other people. We're going to speed up our analysis. Okay, so please join me then. Thanks.